Okay, hello, my name is Dr. Andrew Tickle and I'm the module leader for M07CDE microprocessor applications. Basically what you'll be covering in this module is you'll be learning how to program a basic microcontroller. The microcontroller we'll be specifically using here is a PIC18F microcontroller. So the techniques you learn in this module can not only translate across into other microprocessor-based systems such as ARMs, Arduinos, and things like that, but they also have techniques that can translate across into field programmable gate arrays. So for those of you who've taken M01CDE as an option module, although it is a mandatory module for the MSc in Electrical Engineering, that will also help you with that module as well. What you'll do in this module is we'll start with some basic calculations. We'll go over some basic fundamental aspects of C programming to actually get everyone up to the same level before we actually move on. We'll then do a few lectures on the architecture of the system, some specific functions such as how to do pulse width modulation, how to do capture compare, and we'll then branch that off. So we'll go into a few lectures on the architecture of the device, then go into the capture compare modules, pulse width modulation, which are all very handy for controlling devices from basic motors to light sources to everything else. We'll then do a lecture on actual color systems and color displays, which will talk about the color environment, so red, green, blue, the traditional one that your television uses, to the hue saturation intensity or hue saturation luminosity aspect of the system and how to translate between the two different color domains. We'll then focus towards the end of the module on how to do things such as CAN bus, USB, and RS232 communication via UART or USART. So that will actually help you with that. Where to actually go with this module, basically any based microprocessor application is good, hence the name of the module, microprocessor applications. For example, a recent example of how this could be used is for Lady Godiva, the big robotic Lady Godiva used in the Godiva Festival, and actually that was actually built using 2 Arduinos and 2 PIC16s, and that was it. And I know that because I was personally involved in building that with the company that designed it, and that's it. So what you do in this module, you could actually do in that, apart from that, the way the module is assessed is there's 2 pieces of coursework. There is one which is a individual coursework which you would go away, do a bit of research on a topic, and you would submit like a research paper that we would mark and grade. That is worth 30% of the module. The other 70% is based on a group-based laboratory assignment where you would then work in a group and focus on a specific task. So each group would have a different set of specifications to stop yourself from copying off each other, which I must emphasize is a big no-no. So I'll handle the lectures side of the module. My assistant lecturer will handle the laboratories. I will come into the laboratories every now and again, but the bulk of the laboratory work is supervised by the TA, stroke assistant lecturer. So I will hope that you enjoy this module. I hope you find it interesting, that you'll find it useful. And if you need anything, you're always welcome to give me an email or to give me a phone call to my office. Thank you very much.